Sequences. Sequences are ordered lists. 1, 2, 3, 4. Here's this familiar letter sequence, C, D, E, F, G, A, B. The 7 notes of the C major scale. Here's another way to see the sequences for the 7 notes of a major scale, any major scale. 0, up 1, up 1, up a half, up a 1, up 1, up 1, up a half. A phone number is the sequence. When we say a phone number, we don't say open parenthesis 415 close parenthesis 555-1212. We just say the numbers in an ordered sequence. 415-555-1212. And the order matters because 415-555-2112, that's a different phone number. It's fun sometimes in math to always talk about what goes wrong and what isn't a sequence. So something like 2 plus 4 has 2 numbers in it, but it isn't a sequence. It's a sum. A sequence has to be a list. And the other thing about sequences is they have to be in order. But the thing is, once you learn any kind of definition, my advice is to try to think of as many different examples of that definition as you can. How many examples of ordered lists can you come up with? Behind me is a picture of some toes. And you might remember the old rhyme, this little piggy went to market, this little piggy stayed at home, this little piggy ate roast beef, this little piggy had none, and this little piggy went wee, wee, wee all the way home. There it is, wee, wee, wee. So there's a sequence that has to be said in order following the toes. Here's another example of a commonly occurring sequence, the combination for the combination lock. It's a sequence of 3 numbers. In order to open this lock, you have to turn the dial twice around to the right and reach the number 12, and then once around to the left, reach the number 17, and then back again to the number 33. The combination is 12, 17, 33. You have to do exactly those numbers in exactly that order. Here's another example of a sequence. Number 1, use a large saucepan. Number 2, add contents of package, etc. Number 3, return to boil, etc. Number 4, remove from heat, etc. Number 5, drain well. This is a list of steps, and the steps are in order, and the order matters. You don't want to drain the noodles from the pot before they are cooked. Do not do step 5 before you do step 3, for example. Here's another example of some sequences. I'm looking at a computer, an internet page. I did a search on Unicode for the letter H. So when the letter H is encoded in a web page that uses Unicode, it thinks of letter H as the sequence 0048, or the integer 48. That's for uppercase. And if you look down further, it says UTF binary, there it is, 011010000. So that sequence of zeros and ones means to your computer the letter H. If you were to change those letters, those zeros and ones, or put them in a different order, it would be a different letter. Okay, so sequences can be finite, like most of the sequences that we've talked about, like this one here, ILOVEMATH, a finite sequence of letters that has an order that is meaningful. Here is, but sequences can be infinite. They can consist of infinitely many terms. Each item in the sequence separated by commas, each item is a term. Here the first term is 1 over 1, the second term is 1 over 2, the third term is 1 over 3, and we can go on and on and on. 1 over 4, 1 over 5, 1 over 6, 1 over 7, and we can keep going. Here's another infinite sequence, 1, 10, 100, 1,000, 10,000, and we go on and on. Here's another 5, 10, 15, 20, and it goes on and on. In a way, I pretty much know everything there is to know about this sequence because I know the first few terms and I know the pattern. Do you know the pattern for each of these? We're going to talk a lot more about that later. Okay, that pretty much wraps up this video about sequences. This time we have just talked about the definition. Sequences are ordered lists. Each of those words, order and list, has a meaning, and I hope that that's clear by now. We went through a bunch of examples: a musical scale, a phone number, lock combination, data encoding on the computer, mathematical patterns that are best expressed in sequences, a nursery rhyme, the toes and the pigs, pasta instructions, and having seen all that, the best way for you to really understand the definition, just the definition, is to think of as many examples as you can of sequences. There are a lot more. Happy thinking.